Everyone, today we're going to do our first session, our first video session of Math 208. In Math 208, our first module covers some introductory terminology, which we're going to cover today. It also covers some graphics, which we'll cover on a video session in a couple of days. And it also covers some measures of central tendency, and we'll cover those in a few days as well. Each of those on video, and each of those are included in the supporting document. Okay, so let me share the screen with you. The actual supporting document. This will be in your news item along with this video. So the first thing I want to talk about before we actually do number one is I want to talk about what statistics is. So what's statistics? Statistics is really just the science of looking at information. Information is called data. Data comes in two different types. One type of data is called quantitative, which is numeric. So things like your weight or your height, okay, or your income. Okay, those are the number of miles you drive back and forth to work. Those would be numeric or quantitative data values. Other type is qualitative or categorical. This would be non-numeric, even though they might have numbers associated with them. They are not really numbers you do math with. So for example, your zip code. Nobody calculates and adds up a bunch of zip codes and then calculates an average for them. That makes no sense. This class is coded as Math 208. That's just an identifier that has nothing to do with the number 208. Okay? Other things that are non-numeric would be things like your opinion or your favorite color or the type of car you drive. Okay? So let's give an example in question one of levels of measures of variables. So what's a variable? A variable is something that we actually can give an answer to in statistics. It could be an answer to a question, okay? Like how tall are you? The variable is height. How much do you weigh? The variable is weight, okay? What's your favorite color? The variable is favorite color, okay? And so there are four levels of measure for a variable. There's nominal and ordinal, interval, and ratio. Okay, so let's look at nominal. Nominal ordering doesn't matter. Examples for nominal are color, your sex, zip codes, phone numbers, types of car driven. I can order that any way I want. Now, note, those are all qualitative. So nominal can never be quantitative. Okay? There's ordinal. Ordinal is also qualitative. Ordinal means that the qualitative information can be ordered and must be ordered to make sense. So for example, small, medium, large. Those would be answers to a qualitative variable that's ordinal. Your opinion on an issue: strongly agree, agree, neutral, disagree, and strongly disagree. Those would all be ordinal levels of measure. Rankings of football teams would be nominal or ordinal rather levels of measure. Okay? Interval is a segment of numbers. Okay, so this is numeric. This is quantitative. Okay? There's no meaningful zero, however, with interval notation, or interval values, I should say, measure. So interval measure, no meaningful zero means what? Let's take temperature. 0 degrees Fahrenheit means it's pretty darned cold. 0 degrees centigrade or Celsius means it's freezing, and at the freezing level from water. And 0 degrees Kelvin means that everything, all molecular motion in the universe stops moving. So there are different measures that have different meanings for zero. So that means that it has to be interval. So temperature is the classic example of interval notation or interval value. Ratio. Ratio is a segment on a number line with a meaningful zero. Examples could be length, weight, task it takes to do something, or wait time. There's a beginning and end there. How long it takes to listen to a record or a music video. How long it takes to listen to this video. That would be ratio. Be alert with time, however. It takes to do something, wait time, or run a race or something of that nature has a meaningful zero. Whereas clock time in the AM/FM sense, AM/PM sense rather, or the universal time sense has no meaningful zero. In fact, in the historic or universal sense, zero is not ever defined. Okay? So meaningful zero would be impossible there. Let me scroll this up a bit. So here's another question. Okay, we have 1,200 Delta College students, and they were asked if they were aware of the services provided by the Teaching Learning Center, or TLC. Their responses were coded as yes or no. Based on this information, is the response quantitative or qualitative? Well, yes or no is not a number, so it would have to be qualitative. Let's look at part B. What is the level of measure? Well, yes, no. No, yes makes the same level of sense either way. So since it's qualitative and order doesn't matter, yes, no versus no, yes, it has to be nominal. What is the sample? Now, for a sample, we have to be very specific. Okay, so specifically, the sample is not 1,200. That's the size of the sample. Okay, the sample is the 1,200, but what are they? They're Delta College students. So the sample would be 1,200 Delta College students. The population in part D would be everything where those 1,200 came from. So that would be Delta College students. So for D, we would say all Delta College students. Now, for samples, we always give it a size and then we tell it where it comes from. For populations, we always use the words like all, every, each. Okay? If you see those words, you automatically know it's a population. If you see a sample size, a number, then it's probably going to be a sample. It's warning you there's a sample ad. Okay, let's look at part E. If it was found 57% of the 1,200 Delta College students said they were aware of the TLC services, is this 57% an example of a statistic or parameter? So what's a statistic? A statistic is a measure about the sample. A parameter is a measure that's a fact about a population. Now, parameters don't really change all that much. If they do change, it's over a very long period of time. Whereas a statistic changes every time we do a sample. Okay. So since this 57% referred to the 1,200 Delta College students, I would have to say that it is a statistic. If it said it was found that 57% of all Delta College students were aware, then it would have to be a parameter. We have 4 types of valid sampling. One type is called a simple random sample. The simple random sample, we just basically make a computer-generated program that randomly selects a number. And then we call that phone number, or we select that number that's coded up with a name and in our data set. Another type is a systematic sample. So the idea is very similar to this, except that we use the same number over and over again. So we might interview every 10th person in line, or every 50th motor on an assembly line. We might take off and test to see if it's up to quality specs. A stratified sample, sample technique C, is when we have a population that can be layered. So for example, okay, we have younger people, middle-aged people, and older people. Okay. From that layers our population into those subcategories. And so from that, we then can do a simple random sample and determine people from each. And so basically, this gives us not only a random sample, but it also gives us one that's more representative of the population. So it's a very valid and very useful way to look at things if we can layer the population. And then the fourth way, this is typically what they do in emergencies, if they want to figure out how much damage there was, say, from a hurricane or a tornado, or if they want to figure out the census. They use what's called a cluster sampling. And so typically you grid off a large region. Okay? You make little squares, you superimpose little rectangles or squares over a map of, say, a city. Okay? And then you randomly select using a simple random sample or a systematic sample. You randomly select certain grids, a number of grids on that city. And then you interview every item within that grid. So if you leave something out in that grid, you don't have a valid cluster sample. Okay? Another type is what we call self-select, or a convenience sample. A convenience sample is not a valid sample. So when you watch the news or you read a magazine or something on the internet, it says, hey, take our poll. It's worthless. It's useless. So the politician, you say, do you support so-and-so? And do you support these issues that so-and-so supports? And it's on the internet, it's a worthless sample. When they mail out to you that, it's really a worthless sample. It's a convenience sample. You self-select whether or not you will be in it. And that means that there's no randomness to it. It also includes bias. Remember, bias is the idea that if there's a biasness to it, then there's some kind of pattern or there's some kind of situation that is not totally random. Okay? So here are some examples of some of these. Okay? Every 15th person was asked their experience at the movie theater as they were coming out. That would be a systematic sample because we're talking about every 15th person. A community is divided into 3 school districts. 50 people are randomly selected from each. Since we're sub-layering into 3 areas, this would be a stratified. Wait staff asked customers if they would fill out the survey about their service. That's a convenience sample. It's when you go to Taco Bell or Applebee's or something and they give you the receipt and they say, hey, fill out this and tell what a wonderful job I did. That's a convenience sample. Or when they say, hey, fill out this receipt and have a chance to win $500. That's a convenience sample. Okay? All right, so that's really, in a nutshell, chapter 1 stuff. So then next time we'll talk about graphics. And then the third time, as I said, we'll talk about measures of central tendency. Have a nice day. We'll see you next time.